On the night of August 21, 1986, people in villages below a quiet crater lake in Cameroon suddenly collapsed. There was no lava, no wall of fire. Many never heard a warning. By morning, 1,746 people were dead, along with thousands of animals, while most plants still stood untouched. The killer was ordinary carbon dioxide, the same colorless gas in every breath you exhale. Lake Nyos had stored an enormous quantity of it in deep water, then released it in a chain reaction scientists had barely imagined. This is Pip's Fact Orbit. One familiar fact, and a much stranger story. Lake Nyos lies in the green highlands of northwestern Cameroon. From above, it looks peaceful. Dark blue water enclosed by steep crater walls. The lake is roughly 2 kilometers long and reaches about 208 meters deep. Its shape matters. Nyos occupies a volcanic maar, a crater formed by an ancient explosive interaction in the ground. The crater is young in geological terms, but the disaster of 1986 was not a fresh volcanic eruption. Deep beneath the region, carbon dioxide from magmatic sources moves upward through cracks and groundwater. That gas enters the bottom of the lake. Under high pressure, cold deep water can hold large amounts of dissolved CO2, just as a sealed bottle of sparkling water holds carbon dioxide while it is pressurized. Most lakes mix seasonally. Surface water cools, sinks, and exchanges oxygen and dissolved material with deeper layers. Lake Nyos is unusually deep, sheltered, and tropical. Its water column could remain strongly stratified, lighter surface water above, denser mineral-rich water below. Weak mixing allowed carbon dioxide to accumulate in the deep layer over many years. The surface gave little away. The gas was not sitting as one giant bubble under the lake. It was dissolved molecule by molecule in bottom water. Pressure increased with depth, keeping it there. The dangerous part was what could happen if enough gas-rich water began moving upward. Imagine opening a soda bottle. Lower the pressure and dissolved carbon dioxide forms bubbles. Those bubbles make the liquid less dense, so it rises faster. Faster rising lowers the pressure further, which creates more bubbles. In a deep lake loaded with gas, that feedback can become a runaway eruption of water and carbon dioxide. Scientists call this kind of event a limnic eruption or lake overturn, though the exact trigger at Nyos remains unresolved. Proposed triggers have included a rockfall, a landslide, unusual cooling, heavy rain, wind-driven internal waves, or a release that began spontaneously as deep water approached saturation. The evidence does not justify declaring one winner. What investigators could establish was the sequence after the release began. Gas-rich water rose. Carbon dioxide burst out of solution. The expanding mixture accelerated upward and disturbed the lake surface, producing rumbling and large waves. Water washed high across a promontory, stripping vegetation. Deep, iron-rich water reached the oxygenated surface and formed rusty-colored compounds, turning the previously clear upper lake red-brown. The carbon dioxide then spilled over low points in the crater rim. CO2 is denser than ordinary air, especially when concentrated and cool. Instead of immediately dispersing upward, the cloud hugged the ground and flowed downhill into valleys. The terrain acted like invisible channels. NASA later summarized estimates that part of the cloud moved at more than 100 kilometers per hour. Smithsonian reports traced branches north through the village of Nyos, west along the Cha Valley for roughly 15 kilometers, and into other low areas. The deadly effects extended as far as about 25 kilometers from the lake. Carbon dioxide is not a poison in the way cyanide is, but high concentrations are lethal. It displaces breathable air and also raises carbon dioxide inside the body. Victims can become confused, lose consciousness, stop breathing, and die rapidly. The 1987 U.S. scientific team concluded that the victims died from carbon dioxide asphyxiation, and found no evidence that a direct volcanic eruption caused the disaster. Some survivors reported smells like rotten eggs or gunpowder. Pure carbon dioxide has no odor. Trace gases or disturbed natural springs may explain those reports, but the medical, chemical, isotope, and geological evidence identified CO2 as the dominant lethal gas. This distinction matters. Smell was not a reliable warning. The human cost was enormous. A scientific review records 1,746 deaths. The official U.S. investigation described at least 1,700 deaths, and later summaries often round the number. Thousands of cattle and other animals also died. Communities including Nyos, Subum, and Cha were devastated, and survivors woke after hours of unconsciousness to find families and livestock gone. Plants created one of the clues. Many crops remained standing because carbon dioxide does not suffocate leaves the way it suffocates animals. In a few places, the moving cloud and accompanying forces flattened vegetation, but the broad pattern dead people, birds, insects, and livestock amid largely intact plants pointed investigators toward an asphyxiating gas rather than heat. ash, or a conventional explosion. The catastrophe was not completely without precedent. 2 years earlier, Lake Manawan, also in Cameroon, released carbon dioxide and killed 37 people. At the time, the mechanism was still poorly understood. Nyos forced scientists to recognize gas-charged crater lakes as a distinct natural hazard. Teams sampled water at different depths, measured temperature and dissolved oxygen, mapped the lake floor, studied isotope ratios, interviewed survivors, and examined the path of the cloud. The lake's bottom remained flat and undisturbed. Its deep water showed no major new heat source. The evidence supported carbon dioxide entering gradually from below, accumulating in stratified water, and escaping through physical overturn rather than a new eruption. That discovery created a frightening problem. Carbon dioxide continued entering the lake after 1986. Leaving it alone could rebuild the hazard, but disturbing a stratified, gas-rich lake carelessly might trigger the very event scientists wanted to prevent. The solution was both simple and ingenious. A vertical pipe lowered into deep water. Pumps were needed only to start the flow. As gas-rich water rose inside the pipe, pressure dropped, bubbles formed, and the bubbly mixture became buoyant. That rising column pulled more deep water upward, creating a self-sustaining fountain. Instead of one catastrophic release, the gas could escape gradually in a controlled location. Demonstration work began in the 1990s, and controlled degassing at Lake Nyos started in 2001. Scientific monitoring found that the early system reduced the gas inventory without creating dangerous instability around the pipe. Researchers also warned that one pipe worked too slowly and recommended more pipes plus continued monitoring. Nyos is rare, not magical. A dangerous lake needs several conditions together: a continuing gas source, deep water, strong stratification, limited mixing, and enough time for gas to build up. Similar concerns exist at Lake Manawan and at much larger Lake Kivu, but each lake has different chemistry, circulation, population, and engineering challenges. Any crater lake can explode is false. The phrase exploding lake can also mislead. Nyos did not detonate like a bomb, and the deaths were not caused by a blast wave. The central danger was a vast, concentrated, ground-hugging cloud of carbon dioxide. The event was violent at the water surface, but almost silent and invisible by the time the gas reached many homes. Lake Nyos changed hazard science because it showed how a familiar substance becomes deadly through concentration, pressure, and landscape. Carbon dioxide entered slowly, hid in deep water, and followed valleys when released. None of those steps required fantasy, only an unusual combination of geology and lake physics. Today, the enduring lesson is practical. Monitor the deep water. Measure how close it is to gas saturation. Maintain controlled degassing. Map the valleys a dense cloud would follow. Build alarms and evacuation plans around the actual physics. The danger cannot be understood by looking only at the calm surface. So how could a lake kill 1,746 people without lava or fire? Deep water stored magmatic carbon dioxide under pressure. When gas-rich water rose, decompression created bubbles, buoyancy accelerated the rise, and a runaway release sent dense CO2 over the crater rim and down populated valleys. Lake Nyos looked like a body of water. For one terrible night, it behaved like an uncorked bottle large enough to reshape the science of natural disasters.